Yes, sir. Good evening.
Good evening, sir. Good evening. All the participants, please inform your friend circle or any faculty members to join quickly. We have to start our inaugural session quickly. Please inform your colleagues to join as soon as possible. Within 5 minutes, we will start our inaugural session.
9 minutes.
Hello. Good evening, madam.
Good evening, sir.
Good evening, sir. My voice is audible to all?
Yes, sir. Crystal clear.
Okay, thank you.
Good evening, sir.
Good evening, all of you. Please inform all of your colleagues if anybody is there. If they quickly join, in 2-3 minutes, we will start our session. All of you can mute your voice. सर कर दो स्टार्ट की କରିଦେବା ସାର୍ ଷ୍ଟାର୍ଟ 106 ଜଣ ଲୋକ ହେଲେଣି। ହଉ ସାର୍ ହଁ 107 ହେଇଗଲେଣି। ହଁ ସାର୍ 5 ଷ୍ଟାର୍ଟ କରିବୁ। So a very good evening to all of you. I think my voice is audible to all.
Yes, sir, audible.
Start now, sir.
Yes,
You completely audible to start now. Okay.
Yes, sir.
So estimated chief guest, Dr. Madhumita Parada, respected principal sir, Dr. Dilip Kumar Biswal, Dean Academics, and the learned faculty members from various institutions across the nation, the industrialists, and the research persons, and my dear colleague from AIT. It's my distinct honor and pleasure to welcome you to this 5-day faculty development program organized under the prestigious banner of AICT Training and Learning Atal Academy at Aryan Institute of Engineering and Technology, Bhubaneswar. We are incredibly proud to host this program focused on a theme that sits right at the cutting edge of modern technology, next generation aerial communication, integrating AI and drone technology. The focus of this FDP is not just on technology, it is on the future of connectivity. The skies above us are rapidly transitioning to a crucial layer of our digital infrastructure. And drones are becoming mobile communication hub, flying sensor networks, and autonomous delivery agent. That's why the second title is integrating with AI. AI is a brain that manages the dynamic height path, optimize power consumption, allocates network resource in real time, and ensure secure communication link while navigating complex and unpredictable airspace. The objective of this next 5 days, over the coming weeks, our dedicated team of research persons, including leading researchers and industry experts, will talk you through a structured curriculum. We will move from fundamental concept to advanced practical application. Before going to the stage, as it is an online platform, we all want a small lightning of lamp. So now I am cordially invite our principal sir on this occasion to address the audience. Sir, please.
Thank you, Professor. My voice is audible?
Yes, sir. Yes, sir.
Okay.
Continue, sir.
Thank you. So, welcome to Aryan Institute of Engineering and Technology, Bhubaneswar. Respected Chairman, Madam, all the esteemed dignitaries, resource persons, faculty members, and participants. Good evening to all present over here. It is my great privilege to welcome you to the inauguration of our 6-day Atal Fdp development program on next-gen aerial communications, integrating AI and drone technologies. The theme, integrating artificial intelligence with drone-based aerial communication, is not only exciting, but also highly relevant to industries ranging from disaster management and agriculture to logistics, defense, and environmental monitoring. We stand today at a key moment in the evaluation of communication systems. The fusion of AI-driven analytical capability with advanced unmanned aerial vehicle opens new frontiers for automations, precision monitoring, and intelligent data-driven decision-making. Such innovations are reshaping everything from real-time surveillance to rural connectivity, bridging gaps that conventional infrastructure often cannot. Over the next 6 days, participants will gain exposure to cutting-edge developments in aerial communications, AI-driven navigations, real-world applications, and essential safety and regulatory standards. I would like to extend my heartfelt gratitude to AICT Training and Learning Atal Academy for supporting this initiative, to our expert speakers and trainers for their valuable time and insights, and to our organizing team whose dedication has made this event possible. Especially, I can congratulate Mr. Priyachandan Satpathy, who is the coordinator of this event, and Mr. Abhimanyu Kara, who is the coordinator of this event. Let this FDB be a catalyst for innovations, promoting partnership and idea that contribute to making aerial communication smarter, safer, and more impactful through the integration of AI. I wish this program great success and look forward to seeing the transformative outcome it will inspire. Thank you and best wishes to all the participants on their journey over the next 6 days. Thank you.
Thank you, sir. Thank you for enriching word. Now I would like to invite our Dean Academics, Dr. Pradut Kumar Swain, sir. Please, sir, give some address to the audience.
Good evening to one and all who are present here. Honorable Chief Guests and Chairperson, Dr. Madhumita Parida, respected Principal, Dr. Dilip Kumar Biswal, Coordinator of this organization program, Professor Priyachandan Satpathy, and his associates, and all the supporting staff of Aryan Institute of Engineering Technology, and my respect to all the participants, all the research fellows who have joined for these programs. Today, for the first time, Aryan Institute of Engineering Technology is organizing this Atal FDP online, so that there is a hurdles maybe arise, so that I request all the participants to coordinate this program for a grand success here. So regarding the FDP, first of all, I go to my institute Aryan Institute of Engineering Technology. This institute is a premier institute in Odisha, which was established in 2009. This institute is just at the village Borkuda and very near to our Dholi Stupa, that you will see Biju Patnaik. International Airport and Lord Lingara temples here. This institute is surrounded by vegetations and greenery, providing a panoramic view of Bhubaneswar city. So if anyone can come to our institute, you can see that how the situation is there. That's why you are aware that small plants, large plants, everything must be greenery situations available here. And also this institute has a good infrastructures with well-equipped lab and also experienced faculty members, and also classrooms and smart classrooms. And also you are conducting the classes regularly. This is an important point of view here. And also every day you can see that around 1,500 students are attend the classes, and every classes are going on smoothly from 9:30 to 4:30 p.m. The motto of this institute is how give a good relationship between the students and teachers, and so that you can be one of the best institute in Odisha. So this institute has outed the one of the best institute due to its teaching capability and also good management, because this was a 9001 IO system. This was achieved here, and also this was accredited A grades. And also very recently we are going to start the NBA, and the NBA team may come within the November Nodal Center for evaluation of DPOD, and also local center for the NBA. And the main important thing that our missions and the vision of the institute. So for mission vision, I can just give a few lines for you that the main objective of the mission and vision of the institute is to give the quality of education by impacting the quality of education through technical education and produce the graduate engineers with the affordable cost, so that they are skilled and they are able to be dedicated for the service of the society with the least cost, and also in various different ways. This is our motto here. So now I can come to this is issue, and this will continue as usual or further also there. Then I go to the topics now here. So for the topic, I'm telling that here. The next generation aerial communication and artificial intelligence and drone technology. There is a integration of artificial intelligence and drone technology. So my question is, what is drone technology? Drone technology means it is simply a unmanned aerial vehicles. It is an aircraft which flies without a human pilot on the board and operated either by the remote control or autonomously by a computer program. It can be used for a variety of tasks from military and surveillance operations. But question is, what is artificial intelligence? Artificial intelligence means it enables the computers or machines drones to simulations, human-like intelligence. Then what is the integration of artificial intelligence for the drone technology? So drone is a simply remote control. drone is simply a remote control or simply a autonomous equipment with sensors and cameras, which can complete the various tasks, while artificial intelligence that simply simulates human intelligence and can achieve autonomous decision making and learning through the algorithms. Both drone and artificial intelligence, when they are integrated, what happens? You see, drone can collect a number of data, large amount of data by carrying various sensors and cameras, whereas artificial intelligence can analyze the data and process the data to achieve the more application. So what is the meaning here? For the drone technology, I collect a number of data. All data those must be synchronized. And also artificial intelligence just synchronize the data and find the real data. That's why artificial intelligence helps for the new because one input has to go. Changes the target here. Input changes. If the input changes, output changes here. So that time, that was quite essential that integration of artificial intelligence with the drone technology. Drone technology can use all cases here that must be integrated to this here. But nowadays you see the applications here. Every cases you see the applications here. What are the applications of this is artificial intelligence with drone technology here? Suppose you go to the patrolling systems here. When the patrolling systems, the defense systems here, that's why taken the major roles here. Suppose you go to surveillance system, this is also important. You go to agriculture. For agriculture, you just going to find out the soil. That means what is the situation, atmosphere, everything here. You go to traffic position, this is mostly here. You go to logic and delivery system, this is also essential here. But everything is okay for the system. But slight disadvantage there. That is the system is that battery system. Whether the battery is longevity or not. So to try to develop this battery system so that it can work for a long time. So anyway, thanks to all for the presence here. Once again, I coordinate the President Satpathy, who is the coordinator of this program, and all the participants for presence here. So I hope that all should coordinate for the last time because you have to join and also end for the last point and also so that you can be successful. Thank you for again also. Thank you to all.
Thank you, sir, for your describing our college and the topic. Next, I would like to invite our chairperson, ma'am, Dr. Madhumita Parada, to address the audience. Ma'am, please.
Okay. Namaskar and wish all a very good evening. Being the chairperson of Aryan Institute of Engineering Technology, I would like to welcome you all this Atal Online Faculty Development Program on integrating AI and drone technology. At the same time, I would like to thanks and congratulate to the Department of ECE for arranging this faculty development program on behalf of Aryan Institute of Engineering Technology. So, from my side, it's a big hearty welcome and congratulations to all the participants. I hope you will have a very good session. Actually, the thing is that the program is going to be good success because I can see numbers of participants joining time to time, which will give us a positive feedback so that we can go a long way and will bring out lots of output, positive output out of this program. So during the process of development, from time to time, as you know that from very ancient time to till, lots of communication method has been developed to educate, to learn, to teach everybody so that the civilization can develop. So in different stratas of time, we have changed a lot. And the recent innovation, as we are meeting here today, but we are not physically present here. We are only mentally, and we can see each other only through the method, the meeting that is arranged through this Zoom is a newly modified communication method which making all the world into one segment. Now we can learn, we can see, we can feel, we can exist, we can innovate everything through this developed method of communication. Is not it really a good positive aspect for future development of our country? Is not it going to give positive aspects to the teachers, to the faculties, to the new technocrats, those who are facing lots of challenges, they will overcome such type of problems and help the country to grow, and we will give us a comfortable life for everybody from changing different aspects, so that the total scenario will change and everybody will have a very comfortable and sophisticated lifestyle. And the most important thing, very, very small or bigger problems will be solved in a very tiny or fractions of seconds. These are really a very good attempt. These are really a very positive aspect for our future. So this FDP, which is on the trending topic AI and drone technology, I hope is the medium to maximize your knowledge and can be applied for nation's further progress. So, on behalf of Aryan Institute and EC Department, Bhubaneswar, Odisha, expect a good time with you all and hope a very interactive and learning sessions. Thank you so much for joining. Thank you. Thank you so much.
Thank you, madam. Thank you for the enriching word. I would like to introduce our co-coordinator, Abhimanyu Kore sir, for the valedictory vote of thanks. Sir, please.
Thank you. Thank you, madam, for your encouraging and meaningful words. Your speech has truly motivated us and added a great value to this 6 days FDP. Thank you. Thank you, madam. Thank you so much.
Next, before going to our session, I would like to all our participant faculty members, you are the touchmaker who will shape the next generation of engineers and technologists. This FDP is your platform to unlearn, learn, and collaborate. I urge you to engage enthusiastically, challenge our speaker with your insights, and foster a strong network that extends far beyond the duration of this program. We are at AIT believe this FDP will be a transformative experience, empowering you to lead the charge in this thrilling new domain. With immense hope and enthusiasm for the fruitful discussion ahead, I officially declare Atal FDP on next-gen aerial communication integrating AI and drone technology inaugurated. Thank you. Thank you all. Just take 2 minutes. I will introduce our session 1 resource person. Be there. So today we will have Kaushik Mahanti, the project associate, National Institute of Electronics and Information Technology, NIEL IT, Bhubaneswar. Kaushik Mahanti held an MTech in Communication Engineering from Jadavpur University, Kolkata, with 20 years of teaching experience. He has been associated with consultancy work for different industries such as Tata Steel, Vedant, and L&T, and their vendors, etc. He is now working as project associate at National Institute of Electronics and Information Technology, NIELT, Bhubaneswar, Government of India. He is now associate also with Unmanned Aircraft Vehicle project under IIT Kanpur, sponsored Ministry by Electronics and Information Technology, Government of India. He has 3 papers of publication in IEEE ADS section. He has a lot of experience in the field of Internet of Things, communication, and ELE. We heartily welcome you, sir. Please join the session and take after me. Thank you all. Be patient. Sir will joining in a very short manner.
Thank you. Thank you, Priya Chandan Satpathy sir. I am very much happy to join this program. And I am very much happy, first of all, to see a large number of faculties and participants here to join this 6 days faculty development program. No doubt, this is a very means recent topic where we have some focus to be have by Government of India, and no doubt there is a aerospace engineering branch in BTech. But why we are discussing about all these drones nowadays? That is a question. And first of all, I will try to clarify the technology behind this drone, whether it is a new technology or it is a old technology, and what are the recent technologies development with respect to that drone that we have to know, so that our students will pursue their career for MTech as well as for PhD in drone technology. We have recently come across the development in the unmanned aerial system or unmanned aerial vehicles, which are there for Iran, Israel's. No doubt they are very much ahead of us, but we have to develop our own drones or unmanned aerial systems. That's why we are urging our students, we are focusing our students, and we are conducting some of the recent programs upon this drone or unmanned aerial system to have some awareness among all the students, whether irrespective of any branch they may pursue their career for aerospace from drone sectors, because drone is not related to a particular branch unless until our faculties as well as our instructors, they have sufficient knowledge regarding this thing, our students won't get sufficient knowledge. That is our motive through our METI, Ministry of Electronics and Information Technology, and I am also working upon that. Anyhow, myself, Kosik Mohanty, I am working as a project associate at National Institute of Electronics and Information Technology, Bhubaneswar. We are under IIT Kanpur, Professor Abhishek, who is our leader, who is our guide, and he is a scientist for VTOL and helicopter. No doubt, we have developed so many types of unmanned aerial system. Right now, our sir already has discussed so many things regarding that drone. Is it audible to all of you? Am I audible to all of you?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Fine,
Yes, sir.
fine.
Yes, sir.
Thank you. So my point is that before many years, electro locomotives are there. It is possible to drag very heavy wagons, but only 4 to 5 years back, if you look, EVs are there on the road. Motors are already have been developed by the scientists. Batteries technology have been developed by the scientists. And why the EVs, which are very small things compared to your that electro locomotives, came after all these things? So that is the point. Just like that, helicopters are much before that. But nowadays, drones or unmanned aerial systems are there very much. Let us say before 10 years or like that. The technology behind the aircraft, which is followed less or more in drone systems, we have to study. And the battery technology, before 20 years, one of my students has delivered one seminar. He has told a battery just like a thin like a paper, which was developed in Japan, and that is nothing but your lipo batteries. If you find out, it is wrapped just like a paper inside your mobile battery, lipo battery. Now, due to the technological advancement, nowadays we are able to get the form that EOS that we are getting in the form of quadcopter or fixed wing. From World War I or much before that also, unmanned aerial systems were there. But the form, the architecture has been quite different from those days, and it has been changed dramatically. If you look into the architecture of a drone, whether it is a fixed wing, whether it is a VTOL, whether it is a multi-copter version. Anyhow, let me discuss the architecture first of all, so that we may get the idea regarding what sort of thing it is and why it is called unmanned. But the definition is quite different. If I talk about the application, you will find there is somebody on board, whether it is a pilot or whether it is a passenger. Then we may not call it unmanned. If there is a person inside a drone or a unmanned aerial system, then it is no more unmanned. So we have developed passenger drone also. In near future, China has already introduced air car, means which may be able to take one person or two person through that drone also. Then it is no more unmanned. So depending upon the application, it is not limited to only defense or some of the applications. It is very much there for agriculture, for medical sector, for defense, for other application. Even firefighting drones are there. Through firefighting drones, it is nowadays very much popular and it is very much essential, because there are very high rise buildings are there in every cities. You just think one of the application, if there is a fire breakdown at 11th floor, is it possible to any human being to reach that height instantly? No, it is not possible. But it is possible for a drone to drive to 11th floor and you may get the solution to douse that fire. So many applications are there. Drone is not limited to defense only. So many applications are there. That's why this present generation, they have to know regarding that thing. The civil engineer students are equally, they are using the drones, they are taking the advantage of drones for survey work, for mapping also. Through orthomosaic mapping, they are getting the solution very quickly, without having losing so many manpower, or without having so much manpower. They are possible to get the orthomosaic mapping or survey works for different mines area also. So let me start the session regarding the architecture. I will discuss some of the hardware part, because unless until you know what is our objective, we have to integrate the drone with some of the AI or other new advanced technology. Without knowing the hardware and software which are there already developed for the drone, it is not possible to get the idea how to integrate the next generation AI, artificial intelligence, or any embedded intelligence inside its flight controller. How many things are there? What are the different components? What are the different parts? So that we have to calibrate from time to time. We have to take the sensors input towards the flight controller, and the flight controller, it uses the Kalman filter to have the output instantly. That is the magic of that Kalman filter, by which it is so much stable. Nowadays the drone is possible to get the desired path, desired waypoints. We may get the autonomous path also. So here is the overview of UAV architecture. We'll discuss less or more hardware, software, and the communication layer. Basically, it consists of hardware, software, and the communication, because so long as it is an unmanned aerial system, so from the ground we have to control the device. There is nobody on board. We have to control the device, means suppose the flight, which is a flying object, it should get some command from the ground station, whether it is from a remote control, whether from a laptop, whether from a PC. Through some softwares, it will get some instructions that is in the coded version, and accordingly it will act. Sometimes in autonomous mode, the embedded program artificial intelligence follows the path and it satisfies the results. If it is that, then it will again proceed for the next job for to do. Next, we will discuss about the integration of subsystems, how all these parts are integrated. All these things we will try to find out. So basically the drone systems depends upon the airframe, propulsion system, power, flight controller, sensors, communication module. Now here is a point, propulsion. For every system, the propulsion systems are different. For every systems means for aircraft, ramjet engines are there. For rocket, jet engines are there. For helicopter, the engine is something different. For drone, is it equally valid? Those engines are equally valid for our drones? No, it is not possible. Perhaps sometimes a two-stroke engines are there for drones. Sometimes the ramjet engines may not be suitable for a drone. So what is the new technology during this period they have developed? We have to know. And what are the flight controller? Just like your aircraft, inside every drone, there is a flight controller, which is the brain of a drone. And no doubt, sensors are nothing but the actual input parameters that is very much required for your flight controller to decide what should be the speed of each of the motors, which are nothing but your BLDC motors, brushless DC motors. And the communication module, that is very much essential. We just generally nowadays we are using 2.4 gigahertz frequency or 5 gigahertz frequency for the communication purpose. But in future, we may switch over to any other band also and other coding system also. So depending upon the generation requirement, if we develop new technology, then the drone concept may be different. Because before 50 years, the unmanned aerial systems are quietly different. But nowadays, the unmanned aerial systems are very much different from those days. Now come to the types of the drones. Actually, I will show some of the hardwares here. There are basically three types of drones. One is fixed wing, another is multi-rotor, another is VTOL, vertically takeoff and landing. So what are fixed wing, multi-rotor, VTOL? You try to find out from this structure. Fixed wing means this is just like a airplane. Are you getting the result? How it looks? This is nothing but aircraft, and it has some fixed wings. How many degrees of freedom? 6 degrees of freedom, because if you consider x-axis, y-axis and z-axis, then it may move forward or backward, left side, right side, or it will move like this, means it will rotate about the z-axis. So moving across x-axis is known as pitch. If it moves across the y-axis, then it is known as roll. If it moves across the z-axis, then it is known as yaw motion. So according to aircraft phenomena or aircraft language, we call it pitch, roll and yaw. There are three types of motion, and other than these three types of motion, for fixed wing there is another motion which is known as if you try to move directly upward, or if you try to move downward, that is known as throttle. In multi-rotor, that is another type of drone. Here I am showing you this type of drone. You try to get it. This is another type of structure where multi number of motors are there. That's why the name is multi-rotor. I am showing you a quadcopter here. This is a quadcopter. Along with that, some of the other components are there. The frame is just like what you are observing, red and white. But other than that, some of the other parts are there. This is one of the flight controller, and beneath that, power distribution boards are there. Many things are there. One by one, I will discuss about that thing. But this is my point is this is multi-rotor. The previous one is fixed wing drone, and VTOL is a combination of these two types, fixed wing and multi-rotor. I am showing through some diagram. You try to get it. The first one, this is fixed wing drone. The second one, multi-rotor, and the third one is known as mixed type or VTOL. These three categories are there, but if you want to segregate into different categories according to its weight, according to its number of motors, you may name it accordingly. But how it is different from airplane or aircraft? For general aircraft, we need a runway. But for general drones, if you talk about the quadcopter, copter version, multi-rotor version, we don't need any runways. It will take off directly from any particular point, and it may get down at a particular point also. So this is nothing but the advantage over that aircraft or fixed wing version. But fixed wing also sometimes it doesn't require any runway. For defense sector, they just put it in a just like a missile. That means they will put upon a vehicle and they will project it with some just like a projectile motion. And for VTOL, which is a mixed type, it is also possible to raise the height vertically directly. That's why the name is vertical takeoff and landing. But in mixed type, we achieve two things. One is the copters, multi-copters advancement, that is taking it up or down directly from a particular point, and the high speed horizontal motion just like your aircraft, it is also possible to achieve. That's why we have developed VTOL type of drones. In IIT Kanpur, they are doing VTOL types of R&D works where our defense sector is in requirement for that VTOL also nowadays. Now let us come to the propulsion system. In earlier days, just like I have already told you, electro locomotives already there before 20 years, before 30 years, the motors they have already developed. But the motors are generally, if you talk about the DC motors, that is a brushed motor. That means the commutators are there, just like a half circle, and the carbon brushes are there, which are in contact with the commutators. But in brushless motor, they have already diverted from that brushed motor to some extent. For what purpose? To minimize the friction. It doesn't require the replacement of that carbon brush. Also, we don't need from time to time to maintain that maintenance work is not required. So I will show some of the videos here with respect to a brushless DC motor, and it is a very complicated concept. We have to switch the power supply from one point to another point. That means the phase is relatively changing. Accordingly, the dimension is different or the polarity of the magnet is different, but it advances in a particular direction. Now I will find a video for you. Try to get the videos and find out the solution how to switching that armature winding coils in a very rapid manner, so that brushless motors they will achieve very high speed. For drones, we need very high speed motors. With the brushless concept, we have already developed very high speed for our motors also. Let me switch over to the video. Please go through this video. Here are three pairs of winding. Permanent magnets are there, but there is no commutator or any type of carbon brushes. Just mark how the concept they have developed to achieve the brushless concept. It is just like that. You have to develop south and north pole from time to time, and you have to switch over from south to north, north to south. But the advancement for the armature or the upper side, the magnet with along with that outer enclosure advances in a particular direction. That is the most interesting part in case of your brushless motor. If you join a propeller with this brushless motor, it will give very high thrust. In physics, there are two rules which are followed for aerodynamics. One is Newton's third law, another is Bernoulli's equation. And from the very beginning, if you talk about the Wright brothers, from that period, they have already followed the nature's rule, which is followed by birds. Everything is there in the nature. We have to discover. When a person gets some knowledge regarding that nature, it becomes a science. So everything is there. Nowadays, the drones are also based upon that bird's wings, which is nothing but your airfoil. I'll show the airfoil concept, how it is possible to lift a very heavy aircraft in the air. If you know the aerodynamics for aircraft, then you will get the solution to develop new kinds of drones or unmanned aerial systems. Now, I am talking about the flying technology which is there for any aircraft. And less or more, this is applicable for our fixed wing drone also. If you know the dynamics, if you know the structure of a drone, then it is required to control that one. So how to get the artificial intelligence to control that one? Unless until we know the architecture. What are the forces which are there for any aircraft or flying objects? So basically there are four forces, and it is just like your physics. You may discuss along with your student also if it is required. Weight, lift, drag, and thrust. Engine, the ramjet engine, which is there just below the wings, only generates the horizontal motion. It is not responsible to generate the lift directly. Indirectly, it helps to generate the lift force, but weight is always there. Whenever the lift force is more than that weight, then the aircraft makes the upward motion, which is known as throttle. We may say the drag force and thrust force, which is just opposite to each other. How it is generated? Because whenever you just mark, let us say you are moving inside a car and you have kept your hand behind that window. If you make certain angle through your palm, you will find some forces there which drags your palm backside. So automatically when you are moving forward, the drag force is in opposite direction. So if you stop your car, there won't be any drag force. So unless until there is some initial thrust, there won't be any drag force. And due to this thrust force, the drag force is generated. And thrust is generated by the engines. The engines are responsible for the horizontal motion. If you make this hand, if you let us say mark the angle, if you make this angle 0° with respect to your x-axis, that won't be maximum drag. If you make it little bit 30° or 45°, the drag is more. You'll find somebody is pulling this hand towards your sky. So this is the mechanism behind any flying object. I will try to find out the different components in case of a drone: the frame, BLDC motor, ESC electronic speed controller. The BLDC motor needs a special type of controller which is known as electronic speed controller. The most important thing is flight controller, where a microcontroller is there, embedded programs are there, and all the sensors, baro, gyro, accelerometer, altimeter, all types of GPS sensors. Many sensors inputs are there for flight controller, and the flight controller takes its own decision to decide the speeds for each of these motors which are associated with a frame. And different kinds of GPS. GPS means GLONASS, GPS, many types of global positioning systems we have to integrate also. And the most important, the battery. Whether the fuel is always battery? No, nothing like that. Nowadays, we are having different kinds of fuels for our drones also, from solar panel also, from hybrid engines also. Hydrogen from the air, it may act as a source of energy for our drone nowadays, and hybrid engines they have already developed. Your drone may fly for several years, not for several months. You may imagine how it is possible. In IIT Bhubaneswar also they are working over that. They have already developed very high speed BLDC motor. And obviously, so long as this is a communication system, wireless communication system, antenna, receivers, and for every drones for different application, whether you talk about your agriculture, for healthcare, or for your defense, for surveillance, for any purpose, let us say for video or photography or any application, you need cameras. But cameras are of different kinds, not only RGB cameras, but also thermal cameras, ladder cameras, many types of cameras nowadays very much popular for our drones also. And what sort of sensors are there? Ultrasonic sensors. Sometimes it acts as a avoidance, obstacle avoidance sensors, collision avoidance sensors, Aiet sensors are there, accelerometer, altimeter, many types of barometers. Many sensors are there unless until the sensors they have developed into miniaturization, it is not possible to put all these things inside a very small drone. You might have come across the DJI drones. It is very small one, but very much capable of doing very different kinds of jobs for survey work, for surveillance work. In marriages also you have come across for photography, videography. So many works it is possible to solve only due to the presence of different type of sensors and the highly sophisticated sensors they have integrated with the flight controller. Already I have discussed drone types: multi-rotor, fixed wing, single rotor, and VTOL. But remember, all these drones are having different kinds of dynamics. For example, I am discussing about the dynamics. The aerodynamics, which depends upon the fluid dynamics and computational fluid dynamics. Your air also acts as a fluid, and fluid inside that fluid, if a moving object is there, then we'll call it the dynamics with respect to that fluid. So we have to study about the fluids in aerospace engineering. The students they have to go through all these through a semester. The fluid dynamics tells us the different mathematical aspect, how it behaves with respect to a moving object, and different conditions according to its dimensions, according to its architecture they have to develop. And the computational fluid dynamics modeling through some softwares which is possible through ANSYS software. Also different types of structures they have designed, and they have some R&D types of works. After that they have developed the different kinds of drone which are there nowadays in our daily life. Now let us talk about the principles behind a copter version of drone. We are having weight, mark here, weight, lift, thrust, and drag. 4 forces are there. But how the thrust is generated? Whenever a moving propeller is there, propeller is just like your fan blades. When the propeller is moving, the air is pushed downward. Simply a small child also say that. But what is the physics behind it? That is nothing but your Newton's third law. If you try to find out the principle, with respect to a airfoil. Here the airfoil I am showing you. The airfoil shape is just like a bird's wing. It is little bit curved one at the upper side and it is almost flat at the downside. Different kinds of airfoils are also there, but in older days they have followed this one from the nature also. From birds' wing they have followed this one, and they have observed something, some force, some uh, extraordinary force they have observed, which is there to lift that aircraft or your airfoil. Mark how it is possible. Here the Bernoulli's equation is there, which is observed. Let us say this is the angle of attack for the airfoil. Now the when air strikes over here, it gets divided into two parts. One follows the upper side of the airfoil, another follows the lower side of the airfoil. But the distance from the tip of the airfoil to the bottom or the last position, tail position, is less compared to the upper side, because the upper side is the curved one. So the air has to take much more path compared to your lower side. So what happens? Automatically very low pressure is generated at the upper side and very high pressure of the air is generated at the lower side. That is the Bernoulli's principle. Pressure head plus gravitational head plus velocity head should be always constant. If you increase the pressure, velocity decreases. If you decrease the pressure, velocity increases. Always this principle is there for airfoil. So as a result, what happens? From high pressure area, which is there at the bottom, from high pressure area towards the lower pressure at the top, the air flows. As a result, the airfoil, which is already attached to the fuselage. Fuselage means the body of the main body of the aircraft is gets some lift force. Now it is ready to move upward. Due to this airfoil nature, due to this airfoil design, it is possible to put a very high weight of aircraft in the air. Are you getting the meaning? The engines are not responsible. Rather, the airfoil gets the lift force rather than the engines are responsible. Engines are indirectly responsible. They are the resultant horizontal motion is achieved by the ramjet engine, but the lift force is generated by the airfoil shape. This airfoil nature is already there in case of rotor type of drones. In the propeller means the blades of the motors, they also follows the airfoil shape. Due to that airfoil, you just think inside our ceiling fan also this happens. If you make it flat, there won't be any air downward. If you make it little bit bent, then the air will move downward or upward. So that is the Newton's third law. That means whenever there is a action, there is equal and opposite reaction. So the action is pushing the air towards any particular direction. The opposite, you are getting the thrust. So here are two principles. One is Newton's third law, another Bernoulli's equation, which are there for any aerodynamics principles or the aerodynamics we may talk about. So the Bernoulli's principle is a fluid dynamics concept that explains how airplanes generate lift and is a key factor in the science of aerodynamics. And it is already before 100 years from the Wright brothers, they have developed this concept and they have followed this concept till today also. Before World War I, unmanned aircraft are there, but nowadays the unmanned aircraft systems or unmanned aircraft aerial vehicles, it is quite different. It is equally valid for that principle, Bernoulli's equations and Newton's third law, but it is attached with so many intelligence, so many sensors, so many digital signal processors, so that instantly you may get the output from the flight controller. There is nobody to control from the ground. We are controlling to some extent the control system to make it left, right, or forward or backward. speak very slowly so and so. Is there anybody is playing some music? I think. Hello. Please stop the music. Okay. So the aerodynamics tells about the air moving over the curved upper surface of the wing will travel faster and thus produce less pressure than the slower air. Is it audible to all of you? Am I audible to all of you?
Yes, sir. Yes, sir.
Yes, sir.
Continue.
Okay.
Yes, sir. Yes.
Fine. Fine. So thus it produces less pressure than the slower air moving across the flatter underside of the wing. This difference in pressure creates lift, which is a force of flight that is caused by the imbalance of the high and low pressure. So due to the pressure difference, it is possible to have that lift force. So if you change the pressure also, it is possible. So that's why in the okay, is there any doubt, Professor Virender? Professor Virender, sir, is there any doubt, sir? Are you having any question to ask, sir?
No, no, sir, no.
Okay, fine, sir. So this is the principles behind the lift force according to your Bernoulli's equation. Very simple physics rule, which is very much helpful to lift for a very high, heavy aircraft, which is possible to make it in the air or put it in the air. So this is the output of a ANSI software from where we are getting the knowledge, the flow, air flow, how it is possible from which side to which side the flow is there, and where is the temperature and the pressure difference. It is shown by different colors, and we may get the knowledge through your software analysis, and we may change our dimensions for our particular drones or the aircraft that we have to make. It is equally valid for your aircraft also, for your drones also. There is some packages in MATLAB also. There are some packages for your drones, aircraft also, and for ANSYS software, it is also equally helpful. Now let us talk about the number of motors and propellers. If it is two numbers of motors, we call it bicopter. If it is there are three propellers, there are tricopter. If four, then quadcopter, just like that. But if you think, if you increase the number of propellers and motors, then it is possible to lift much more payloads? No, not like that. If you want to drive more number of motors, you have to put a bigger size of battery. The battery, if it is a bigger one, then the payload will be more. To lift that payload, extra payload, again you have to think, you have to change the design of motor, you have to replace the motors with again high thrust motors. So there must be some compromise for your design, for your requirement, for your objective. To, let us say, a agriculture drone, it has to spray some pesticide. It has to take, let us say, 16 liters or 20 liters of pesticide. But when you have to transport the medicine, let us say in a mountain area, let us say you have to transport some of the rations for your defense people in a mountain area, then pursued with the payload, maybe 100 kg, maybe 50 kg or more than that. So depending upon your requirement, we have to judge, we have to decide the octacopter or hexacopter versions we have to put for our application. So depending upon these things, always we have to keep in mind the application. Another thing, Newton's third law tells that for each actions, there must be some equal and opposite reaction. Have you gone through a very simple example? I am just putting in front of you. Have you observed minutely if you switch on your ceiling fan, if it rotates clockwise, automatically its shaft will move in opposite direction. But due to it is already fastened with the nut and bolt with your ceiling, it is not further possible to move in opposite direction. My point is that always there is a equal and opposite reaction. So you think a helicopter, when the propellers moves in a particular clockwise direction, its body will move in opposite direction. So who will balance that reaction? There is always a tail rotor. If one moves in clockwise, then you have to put another propeller or a motor. It should move its propeller in anti-clockwise direction. So it is always advisable to drone design to put in even numbers of propellers and motors. But still then tricopters are also there. So two propellers reaction force should be equally nullified by another opposite moving propeller. So all these designs should be inside our brain. So artificial intelligence, whenever we have to put or integrate inside a flight controller, it should take care about that thing. That means clockwise, anti-clockwise, what should be the speed, all these things from time to time. Suppose there is a sudden pressure from air pressure, then what should be the new speed for each of these motors. So all these things, unless until we know the dynamics regarding any unmanned aircraft system, it is not possible to integrate AI or any type of embedded systems inside its flight controller. Now let me proceed a little bit more. Let us say we are driving a vehicle and we want to move, let us say, right side. What we perform to our body, we just tilt little bit like this. That means we make our body little bit bent towards the right side. As a result, we will get some equal and opposite reaction from the road. Coupling effect in physics we have come across in +2 physics. If you remember, if I am not wrong, you try to recall that concept. Just like here also, if it is possible, let us say there is a quadcopter. Please give me that quadcopter. Now let us say this is the quadcopter. Okay. Now how it is possible to move this quadcopter left side or right side? What we do? You have to drive all these four motors in pairs. That means two motors should be driven in clockwise, other two motors should be driven in anti-clockwise to nullify the effect of your Newton's third law. That is already established one. But how to move it like this, or how to move it left side or right side? For that, we have to decrease the speed of left two motors. That means left two motors means one should be in clockwise, one should be in anti-clockwise. These two motors should be slower compared to the other two motors at the right side. As a result, what will happen? This will bend little bit. Automatically, the thrust which is generated at 90°, that thrust will it will resolve into two components in mathematics. If you remember, one is horizontal component, another is vertical component. That vertical component is balanced by the weight, and the horizontal components for each of these motors, if you add, that will result horizontal motion, and it will drive the drone very easily towards any particular right side or left side according to your design or dynamics. So if I summarize this thing, you'll get try to first go through this diagram. I am very happy so many people are there, and we are in the age of drone nowadays, and so many applications are there with the help of drones. Even in California, they have used all these drones to fight with the fires which are there for their forests. Now mark here, two of the motors are diagonally. If you find these two motors in anti-clockwise direction, this one and this one, and two other motors are in the clockwise direction. So this is the requirement for your Newton's third law, because otherwise your body will move. If you drive four motors in clockwise direction, your body will move in opposite direction. But we don't need that one. We want this body should be in standstill position. Motor should only move with the propeller so that it will generate sufficient thrust and it will move upward or downward or any particular direction. Body should be in standstill position. Remember, this is very much essential. In Hollywood pictures also you have come across, sometimes what happens, the helicopter is unbalanced and it is lost in the forest due to unbalance of this body's motion. Anyhow, how much time is left? Okay. Now come to this figure. I am having here 4 quarters. Now try to get the first quarter. What is the meaning of this? I am discussing about the dynamics of a quadcopter. If it is understood, for every copter, whether it is hexacopter, octacopter, we may extend our imagination for any type of or any number of motors or propellers. Here, the first quarter shows you throttle. Throttle means moving up or moving down. How it is possible? Suppose I am having this is in my hand. Okay. Now it moves down. Why? If I leave, it moves down due to its weight, I may say. But when it moves upward, if there is some lift force, if a equal and opposite force is there, equal means it will be held at a particular altitude or height. If the lift force is more than that, then it will move upward. So this happens here also in the first quarter. When it will move down, if the weight is more than the lift force, when it will move up, when your lift force is more than the weight. So this is happening inside the dynamics of a moving drone also. So if you move each of these motors with very high speed, it will generate very high thrust. What will happen? It will generate all together very high thrust and it will try to move your drone upward. When it exceeds that weight, it will try to move your drone upward with some acceleration. That is the physics behind it. Similarly, pitch. Pitch means what? You have come across pitching a ball. In cricket also, we just use this pitch. Pitch means putting it forward or backward that ball in the ground. Just like that, moving forward or moving backward. That is known as pitch. But why it is required? You have come across that flight of or aircraft, when it wants to move up, its head is just little bit, it makes some angle with respect to your ground. And when it tries to get down, the head is moving towards the ground or its tail is moving some angle with respect to the ground. So making it like this or like this, that helps it to achieve the desired pitch. Pitch means moving backward or downward. But in case of quadcopter, how it is possible? This is possible if you drive the forward two motors with less speed with respect to the backward two motors, then you will get moving forward. Automatically, the backside will move little bit upward and the front side will move towards little bit downward, and it will drive that horizontal, due to that horizontal component of the thrust, it will move forward. That is the concept. Similarly, how to make it move backward? Now, two of the backward motors you have to keep with less speed compared with the forward motors. As a result, the resultant horizontal force will help to move it backward. Similarly, another motion is roll. I have already told there are pitch, roll, and yaw motion. Pitch is about the x-axis, roll about the x-axis, sorry, y-axis, and about z-axis means when it try to move like this. This is known as yaw. Z-axis is like this, and if you want to move like this, this is known as yaw. So about z-axis, we want, if we want the motion, what we have to perform? From this figure, you may get the result. Normal speed, it is shown by green. High speed, it is shown as red marks. Let us say this quadcopter is there. Okay. Now, if you want to move, roll means like this. It will move like this. Pitch means moving forward or moving backward. Okay. And yaw means this one. So for each of these motions, we need to keep two of the motors at high speed compared to other two motors at lower speed. And from this figure, the dynamics is very much understood. Which motors we have to keep at high speed and which two motors we have to keep it at lower speed. I think this is clear to all of you. Is there any doubt? Okay, fine. Now, before entering to the next slide, I am showing you some of the components. This is a flight controller. Just like in any aircraft, there is a flight recorder, flight controller. In every drone, we are having a flight controller. These are known as propellers. Propellers are two types. One is clockwise propeller, another is anti-clockwise propeller. But you don't have clockwise or anti-clockwise motor. Generally, we may change the polarity to have desired motions for our motors. But propellers are of two different kinds. One is clockwise propellers. Depending upon the resin parts, you may decide whether it should move in clockwise or it should move in anti-clockwise. So it will generate the maximum thrust according to its design if you try to drive accordingly with respect to your motor. So we have already discussed all these points. So let me proceed little bit more. Now let us discuss about the power distribution and LiPo battery. Now the batteries are very much intelligent, isn't it? Our mobile batteries are also capable of giving some information how much battery is left over and at what speed it is charging. Also, the battery temperature is indicated by the sensors. No doubt, for our drones, it is equally valid. Let us say your drone, you have driven 5 kilometers away from you and 10% battery is left. Now, how to decide at which speed it should return to its initial position? It automatically, its intelligence automatically decides at which longitude, latitude it is placed now and how much time it will take with 10% battery and what must be the speed. So the flight controller decides because that is the brain of the drone. So it will decide at which speed it should move. If it is more, then battery may be drained within that time period. So it is not possible, then it should get down at that particular place instead of moving to the initial position. Try to find out the solution. If it is like that, then you have to put your batteries of more intelligent one. Nowadays, power distribution boards and more battery management systems, more intelligent battery management systems are there, which are there inside a battery. I am showing all these batteries. These batteries are of LiPo batteries. Due to the development of all these batteries, before 4 years, EVs are there. The present versions of drones are there in the market. Due to this only development of all these batteries. If you talk about the nickel cadmium or lead acid batteries, it is not possible to drive your drone or EVs for a long time, long duration. It is not possible. Now let us talk about the flight controller architecture. Inside every flight controller, there is a IMU, there is a barometer, magnetometer, sometimes accelerometer is also there. And the PID controller, which is the heart of a flight controller, is equally intelligent to design any flight controller more accurate to achieve that flight with respect to the desired objective. So there are different kinds of flight controller along with the PIDs. I will discuss about IMU and PIDs after some times, and the main processor and the sensors also equally important for any modern unmanned aerial systems. The PID controller is an instrument that receives input data from sensors, calculate the difference between the actual value and the desired set point, and adjust the output to control variables such as temperature, flow rate, speed, pressure, and voltage. You just think, suppose your drone is 2 kilometers away. You don't know. The altitude is, let us say, 2 kilometers. I am talking about the altitude, not the horizontal distance. At 2 kilometers above the sea level, what is the air pressure? What is the air speed? You don't know. But your drone experiences that pressure with respect to the altitude, also the air speed. So ultimately, you are not the deciding authority. Deciding authority is your flight controller. So your flight controller must be equally intelligent to decide the speed of each of these motors. I've already given the idea. If the motor speed is different, then it will move in a particular direction. To make it more stable, we have to design a flight controller very intelligently so that your artificial intelligence is capable of putting that drone in a very stable condition. In India, all the IITs are divided to have different kinds of R&D works. IIT Kanpur, they are doing aeromechanics, flight engineering. It is the job of IIT Madras. Stability, navigation, and control system, that is the job of IIT Bombay. We are under IIT Kanpur. We are also doing some sort of R&D work upon air mechanics. So every IITs, they are also conducting several courses. MTech, they have already started in every IITs upon drone. NITs, they are in pipeline to start their MTech courses in drone. Perhaps recently I have come across in NITs, they have already conducted more than 22 programs upon these drones. Perhaps they will start this year the drone MTech course. NIT Raulkala, NIT Calicut, NIT Durgapur, they are in pipeline also to conduct MTech courses. Anyhow, so PID, it does this through three mechanisms. One is proportional control, which reacts to current error. Next is integral control, which addresses accumulated past errors, and derivative controls. So proportional, integral, derivative, the name is PID. And the derivative control, which predicts the future, as the PID control sums those three components to compute the output. This architecture allows PID controllers to efficiently maintain process control and system stability. So PID inside a flight controller is a vital part that we have to design, modify for our particular purpose. That is the job of a computer science engineering student or an engineer, and equally it is required on the part of a electronics engineer. But the application with respect to other branches, if I say mechanical people will do the aeromechanics, aerodynamics design, whereas the survey application is related to civil engineering peoples. They will have some different kinds of longitude, latitude, GIS, all sorts of works are related to their job. So it is a combination of all engineering. This drone is nothing but all engineering combination, we may say. Now let us say how many types of sensors are there, less or more I have mentioned here. IMU, GPS, inertial measurement unit. IMU, the full form is inertial measurement unit. Inside that, 2 or 3 sensors are generally it is compulsory. More than that, if it is a very costlier one, your flight controller, then the IMU consists of several sensors. Is there any doubt, sir? Okay. Please ask, sir. Chirag Arora, sir, please ask. Any doubt? Fine, fine, sir. I will share all these materials. I will share all these materials. Don't worry. This IMU GPS barometer is very much essential for every drone flight. Global positioning system and sensors, barometers, magnetometer, how to decide the desired direction, north, south, east, west, all these things, along with the longitude, latitude, all these things are recorded inside this flight controller. So we have to put different kinds of sensors, and the most important one is obstacle avoidance. For that we need, just a minute, is there any queries? Will these controls are analog or digital? Yes, sir. Obviously, nowadays some of the sensors are analog, some of the sensors are digital also. And to your knowledge, sensors are based upon MEMS technology. Have you seen the microphone inside your mobile? Have you seen the speaker inside your mobile, sir? To your knowledge, due to the advancement of MEMS technology, the size of a speaker is very, very small inside your mobile. It is possible nowadays. But how much capable it is of generating so much sound? Very clear, no noise. No doubt there is digital signal processing is there. But the speaker size, I am talking about the speaker size. In older days, we have to put a very loud speakers. But nowadays, inside a mobile, very small speakers are there, but it is equally capable of generating some sounds. But it is still there. It is analog speaker. Just like that, for every sensor, you may have sometimes analog, and the processing part is digital. Sensors always converts a physical parameter into equivalent electrical signal. So analog signal is always there. So analog is the input. The sensor ultimately converts that analog signal into electrical signal. After that, you may modify that electrical signal into digital. So it is a combination. Nowadays, all the circuits they have associated with the sensor, they may be analog or digital. But the initial part, the transducer, always it changes the any analog signal into its equivalent electrical signal. There is little bit difference between a transducer and a sensor. Try to get it. There is little bit difference. I am talking about transducer and sensor. Okay, fine. Is there any doubts, Satya sir?
Yes, sir.
Please ask. Sir.
Sir, actually, I have a doubt. Sir, I have a
Please, sir.
doubt that all we know that the sensors, many of sensors we are using in the drones, and there are the sensors are drawing the current from the same battery source that are when the motors are drawing from the same. So much more power is needed to drive. As we know, the all the long duration, medium endurance drones are already there. That operating in 30 hours and altitude of up to maximum 35,000 feet. How they are able to manage the power source?
Sir, to your
So
knowledge,
that
nowadays the drones is quite different. The power supply is quite different. To your knowledge, it is not limited to the batteries only. In our
yes, sir.
lab, also I will show we have developed solar power VTOL. Means we have put not solar panel, solar cells, very lighter cells. There are a lot of research papers are there using solar cells on the
Sir.
wing. The sufficient area is there. It will drive your drone during daytime. But nowadays, there is also solution for night also. I have already talked regarding hybrid engines. It will take the hydrogen from the air. I'll show in one of the slide. Let me clarify your concept. Where is the other slide? Let me show you the hybrid engine. It will drive your, yes, that one perhaps. Let me control it. Yes, you just go through this slide, sir. This is the hydrogen alternative fuel cell.
Well, sir.
There is no limit. It will drive your drone for several years. Have you come across that ferrous ion battery, aluminum
Yes,
battery? It is
yes, sir.
more
Yes, sir.
powerful
Aluminum
than
battery.
lipo batteries. Nowadays in inverter in Delhi, I have come across very small in size. It will drive your inverter in household inverter more than 40 years. Whereas your lead acid battery, it will drive only for 4 years. What is the difference? Try to find out. No doubt the cost is very much high. Now hydrogen hybrid electrical systems, they have already, means both the hydrogen and the batteries, they have integrated. It will start with the battery first of all. After once it is started, it will take the hydrogen from air, whether it is night or day. You don't have to bother about that thing. I am at Aiet. I am just using 2-stroke engines, gasoline engines. I am not using batteries for my drones. I am having videos. I will show, perhaps I am having another slot on 17th. I'll show one of the videos also that day where the drone is driven by 2-stroke engine, just like your 2-stroke two-wheelers. That is also available in net also. You may purchase. Very small engines are there. It will drive till the fuels are there. You may put 1 liter, 2 liter fuels. It will drive for more than that. And refueling is also possible. For example, if I charge the battery with the help of solar cell during the daytime, it will drive for another couple of days, just like our Chandrayaan. 15 days is completely dark in moon. That's why it was a failure case. They cannot revive the battery. If it is of 7 days night, that battery may serve for another couple of years. No doubt they will develop definitely that battery also. So it is not so much difficult to develop different kinds of batteries also. That's why I have, from the initial, I have already told you, EVs are 4 years back on the road. But electro locomotives, means electrical trains, inside that technology they have developed for the motors. Only due to the advancement of the battery. Now the EVs are there on the road before 4 years. But before 50 years, electro locomotives are there. Before 50 years, helicopters were there. But now the drones are there. Before 10 years, there are a lot of advancement in battery technology, battery management systems. In our mobiles also, you just think, sir, before 10 years, in 2000, I have used my mobile with that much of battery, just like a perhaps a pencil box. Now the battery is very much thinner one, and it drives our mobile several days, perhaps 2 days, with so much AMOLED display also. To your knowledge, sir, Nakamura is a scientist who has taken 23 years, but he has some belief. There is some material inside this earth, in this nature. It will generate the blue color light. All the powerful companies, just like your Toshiba, Sony, they are in the run to generate the blue color light. It has taken 23 years. After red, green LEDs, they have taken 23 years to generate that blue color light, because RGB, 3 colors, only generates all other 7 colors. In our LED TVs or laptops, they are having RGB systems. In our general cameras also. But LiDAR camera, thermal camera concept is little bit different. But this belief is there, and they have developed that blue color light. So just like that, everything is there in the nature. You just try to think. A simple example. Lot of advancement, lot of developments are there. 7 colors are there. 7 surs, Sare Gama Padanis are there. Is there any 8th sur? Who has decided this thing? Everything is there, sir, in nature. When we reach at that particular knowledge, we call it science. Yes, that airfoil shape is already there with the bird's wing. I will show that slide also. That
Yes,
airfoil
sir.
shape,
Yes.
already they have followed in 1901 by the Wright brothers. Before that also they have followed. When they came to know, if you change the dimension, the angle of attack, which is the aerospace engineering students they learn, then we may make it upward or downward. Very interesting things are there. Anyhow, sir, I think this is almost clear to you, sir. Hydrogen
Yes,
fuel
sir.
cells they have already developed. No doubt, it may drive your drones for several years. Today it is also there. Okay, thank you,
Sir,
sir.
just a second, sir. Sir,
Huh?
you were saying about two-stroke engine for drone.
Yes.
Is it about turbofan engine, sir?
No. Just like your adiabatic isothermal engine,
Okay.
bike two-stroke engine,
Yes, sir.
means it is a ignition. For ignition, there is a spark plug also. I will show that video also. I am just using that for hobbyist purpose. We are using fixed wing drone with two-stroke engines. Also in IIT Kanpur, they are also using in their lab two-stroke engines drones also. But due to the sound, we don't use two-stroke engines for defense. We need silent operation. That's why we put electric driven drones. That means battery operated drones.
Yes.
That is the means main purpose why we don't prefer that two-stroke engine for defense purpose, because during that operation they don't need any noise. For enemy people, they don't want to alert them. Anyhow, sir, let me proceed further.
Thank you, sir.
Okay. So I was talking about this thing, IMU, GPS, barometer, magnetometer, and other than that, many types of cameras are there. Let us think about one particular application. Inside a deep forest, terrorists are there. How to trace them? Some animals are there. How to trace them? their body temperature acts as a parameter for your camera. Suppose some peoples are there inside a deep forest. No human being is ready to move inside that deep forest. But through drone, there is some limit for human being, drone can solve that problem. Through drone camera, through lidar camera, thermal camera, it is possible. The thermal camera gets some information depending upon the temperature, body temperature, what sort of species it is there inside a deep forest, or is there any trace of terrorist or human being inside that forest. So it is not advisable to put always RGB camera. RGB camera means your mobile camera or general SLR camera. Those are RGB sensors. But other than that, we are having lidar camera, thermal camera also, where many other applications are there. For example, through lidar camera, you may get lidar camera based drone. You'll get how the survey work is done, how the health monitoring of a very high rise, let us say bridge, very high rise structures, they may monitor from time to time. For your knowledge, sir, if let us say very high rise structures are there, nobody can monitor that high rise structures weekly or monthly basis to have any destruction or any deformation in it. But you may put your drones. Last week we have gone to that station. Which station we have gone? Patia station. One people from Hyderabad, one company from Hyderabad, they have come here to have that survey work for Indian Railway through drone, to put another track just behind it. That already 2 tracks are there, they have to put another third. But manually, if they have to survey that work, it was not possible, because it is a dense forest after the Patia station, and during this rainy season also it is very difficult. It is muddy one, and the altitude is very low compared to the place of that rail 2 tracks. But through drone, it is very easy. They are having very sophisticated RGB camera. Through it, they have taken every 10 seconds, they have taken some photographs with the help of some special softwares. For civil people, it is known to them. They have orthomosaic photographic systems. Through it, they may have that area and through which they have to put the truck. Within 1 day, it was completed. No manpower, only one person was there from Hyderabad, from Vizag, and the contractor, they have already established some sort of cabins there, and they have completed that job. Drones are not only for defense. Drones are not only for some particular application. In future, I'll show some of the application. Sky car, air car, already there in China. For what purpose? So many traffics are there. In Bhubaneswar, we are facing lot of traffics are there on road after 5 o'clock. During that duty hour, after 9 o'clock, there are so many. So you have to use air path. It is not a story, sir. Maybe in near future or after our generation, they will have that air car in every house or every offices. Okay, let me proceed the technical part. Next is RC receiver transmitter. Show me the transmitter receiver. Here I am showing one transmitter. This is the transmitter, general purpose transmitter. We may use it for our robotics purpose, for our drone also. Many advanced transmitters are there. This is and frequency hopping. Frequency hopping coding system. Electronics people will understand what is frequency hopping. And no doubt, so long as we are using this transmitter, we have to put a compatible receiver also. Just a minute, let me have some water. How much time left? Okay. Okay. All these things are there along with that telemetry. Telemetry is that sort of transmitter receiver system from ground control station. We have to control our drone through telemetry. Telemetry in the next session, I will show you. In our lab also, we are using telemetry other than that conventional transmitter receiver. Ground control station equally having some sort of softwares. I will show in the second session what are the ground control stations facility to control your drones. We are having different kinds of softwares. Q ground, mission planner softwares are there. This is mission planner and Q ground, and through Mabling protocol, it is generally controlled. Another part is stabilization and navigation. There are two things. One is navigation system for your drone. Unless until your navigation system is very much sophisticated, it is not possible. For example, you want to return or come back your drone to your initial position. Whenever you are flying your drone or unmanned aerial system, the longitude, latitude is always recorded inside a flight controller. The initial position is recorded, it is stored inside your brain. That means your flight controller. When you want to move it back to your initial position, automatically it follows the shortest distance, or you may design your desired path to move back. This is one short example. Suppose in defense, suppose you have to put your bomb or your missile or a suicidal drone is there. You have to put the target, or you want to set your target. That is nothing but putting the longitude, latitude inside your flight controller. Navigation and path planning. This is also needs artificial intelligence, because sometimes we need autonomous mode. You don't drive your drone always. You put it in the autonomous mode. You set your way path. What will happen? This will follow the path automatically. Or sometimes what will happen? Suppose a drone has to approach a missile. It will approach the missile and it will strike with the missile. It will destroy that missile. How it is possible? Laser guided missiles are there. It will change its track. So how to proceed towards it? The warhead is always having some metallic parts. Sometimes some radars are there. So your drones are equally capable of having some radars. In fish doing drones, which are generally used in your defense, they are having radars at the nose point. That nose point follows that missile or any aircraft, and it will strike with that aircraft and it will destroy that one. Let me conclude this one, and next slide we will focus upon this emerging trends. Let me discuss within 10 to 15 minutes, perhaps 10 minutes is left. I will discuss the emerging trends in drone technology. Why drones matter today? I have already told you. Drones are not limited for defense or any particular category of application. Nowadays, for commercial, for defense, for any particular agriculture, health sector, where there is some limit for humankind, we have to put our drone. So how AI and autonomy system is there for our drone systems. Onboard computer vision and path planning is always required for autonomous mode. Autonomous inspection and decision making is always required by the flight controller. For that, we need our AI systems. Edge AI for low latency actions are required. Just a minute. টিপিপিটা তোমরা চলো। Okay. So what is AI and autonomy? Is it audible? Audible? Okay.
Yes, sir. Yes, sir.
AI empowers drone autonomy by enabling them to make decisions and perform complex tasks without human intervention. Using technology like machine learning and computer vision to navigate, recognize objects, and optimize missions. For autonomous mode, it is very much essential. So AI is very much helpful for our drones. We have to develop for our nation, that is Viksit Bharat. We have to develop our own systems. This combination drives application in various fields, including logistics, agriculture, infrastructure, inspection, and disaster response. Have you gone through the recent accident, perhaps last year or 2 years back, Bahanaga rail accident? Through drone, it was possible to save so many lives, so many casualties are there. Nobody is possible to move behind that bogies. But through drone, it was possible to trace so many lives. AI is essential for drones to evolve from remote control devices to intelligent tools that enhance efficiency and accuracy. Edge AI. Edge AI, what is that one? For low latency actions. Edge AI process data directly on a drone's hardware, enabling it to make immediate split-second decisions crucial for low latency actions. We don't need any delay. Low latency actions are required. That's why low latency actions like autonomous navigation and collision avoidance. Suppose for a particular application, for agriculture, let us say, consider an example of agriculture. When you drive your drone, let us say in front of it, there is a tree. Immediately, without having any delay, it should move away from that tree. So that edge AI technology is very much helpful for that case also. This is just a simple example. Unlike cloud-based systems, which must transmit data to a remote server for processing and then wait for instructions, edge AI minimizes this delay by keeping computational local path. Next is swarm systems. It is very much popular nowadays. We come across some of the events where drone swarms are there, some of the figures in the sky they make with the drone flights. So many large number of drones are there. They may have some figures or structures upon the sky. How it is possible? What is the intelligence behind it? Is it possible to put a particular drone at a particular height or altitude for so many times? Yes, it is possible. Now think about 1,000 drones simultaneously. they will hold that particular altitude and they will bring some lights very nicely. It will generate very good structure figures. That is known as swarm, drone swarm. And it is a cooperative multi UAV missions and collaborative mapping for search and rescue. We generally use all these things. In swarm system, drone swarm system, it involves multiple unmanned aerial vehicles working together in a coordinated network system to achieve a common objective, ranging from surveillance to complex military or civilian tasks. They operate autonomously or semi-autonomously using a artificial intelligence and communication to share information and adapt to their environment, with each drone contributing to the overall mission. So the mission is common to for all the drones. Maybe that swarm system helps us to achieve that one. This approach enhances mission success through redundancy and efficiency, as individual drones can be replaced or their functions taken over by the other damaged drones also. Now, what is BVLOs? Beyond Visual Line of Sight. Regulatory push to enable BVLOS operations. Now think about a drone which is 5 kilometers away. It is not in line of sight. So we have to control that drone. How to control that drone? For this one, improved communication systems, detection systems, and avoidance systems we have to develop. It enables long-range deliverables inspection. For example, that means you want to put your rations for defense sector, let us say, behind a mountain. You don't know the location. You have put your longitude, latitude. It is 5 kilometers away from you, but you have to drive your drone in autonomous mode. So it must be so much accurate. The avoidance systems with the mountains should be so much accurate also. So for that case, for long range delivery, we just follow BVLOS technique. For that also, AI is equally helpful. We have developed to some extent all these intelligence which are embedded inside a particular flight controller. Sometimes we have to map all these things through the firmware also. The firmware we have to time upgrade also. Next is sense and avoid, detect and avoid. Now go through this slide. What is there? Let us say there is a very high rise structure and it is a electrical power supply line, high voltage line, but it is not possible to monitor the deformation from time to time. So what is the solution nowadays? The people drive their drones to measure the staggered distance, the distance between two waves, to nullify the effect of coronal loss. Many things are there. It is very easy nowadays to get the solution with the help of drones. And for that, we have to put very accurate sensors, sophisticated sensors, so that the distance, it is measured generally using your lasers. The distance between two waves, sometimes the staggered distance in case of electrical supply for your locomotives, the distance from the rail to the electrical supply lines, which is above that rail, that distance must be equal throughout the track. So that is known as staggered distance, and it is measured through your drone also. Next slide. Now let us come to the hybrid VTOL and he-VTOL. Now it is very much interesting to know, in near future, maybe this will be available in India also, air car. The definition will be totally different. some person is there on board, means some passengers are there, may not be a pilot, but nobody it is unmanned. In India also, for Navy, Varuna drone in Chennai, they have developed. The Navy people may be transported from the deck to the seashore. So it will take the patient from the deck to the seashore, and the definition is totally different. It is no more unmanned. It is manned drone. It is one of the application. We may not say it is unmanned. Still then it is known as drone. And there is also sometimes it moves inside the water. There are several systems they have already developed, and we have to know many things regarding drone to develop our systems. Okay, it's almost 5 minutes over. Let me conclude this one. For the next session, we'll try to discuss about the demonstration of drone communication systems, perhaps on 17th October. And this is the main fundamental things. Unless until we know the dynamics, we know the structure, what are the components, softwares, all the systems, it is not possible to integrate AI for everything, whether it is for control navigation systems, whether for its control systems for its motors, whether it is the command or the coding systems to put inside the flight controller from the transmitter end to the receiving end, and it is a two-way systems, because on board also what is the health of a drone we have to monitor from time to time.
Thank you, sir.
Thank you
Thank you.
everybody. I am very much happy. Almost more than 150 participants are there, and we join this program not only for our benefit, for the next generation, because nowadays all these technologies are there in Ukraine, or you may say Israel. In Israel, to your knowledge, if you find out the videos, there are several drones which pluck the ripened fruits. Image processing cameras are there very fast, means very accurately they process the image, and which is the ripened one, they will pick that fruits and they will put it inside the baskets. Anyhow, thank you.
Thank you very much, sir, for your enlightening and informative speech on drone technology fundamentals, architecture, and emerging trends. Your valuable insights have deepened our understanding of this rapidly evolving field. Thank you, sir. Thank you so much.
Thank you.
Next, we have here Sanjeev Kumar Padmanabhan, electrical engineering PhD from University of Bologna, Italy, 2012. He is a professor in electrical power engineering at the Department of Electrical Engineering, Information Technology, and Cybernetics in University of Southeastern Norway. He has authored over 750 scientific papers and received Best Paper Most Excellent Research Paper Award from IIT Sesicon 13, IIT CET 16, IEEE EE CSI 19, and 5 Best Paper Award from ETA ERE 16, sponsored by Lecture Node in Electrical Engineering, Springer Book. He is a Fellow of Institute of Engineer, India, the Institute of Electronics and Telecommunication Engineering, India, and the Institute of Engineering and Technology, UK, and a Fellow of the European Academy of Science, Belgium. He received a Lifetime Achievement Award from Marquis Who's Who, USA 2017, for contributing to power electronics and renewable energy research. Sir, please continue your session, sir.
Thank you very much for this invitation. Good evening to all the colleagues in India. and good evening from Norway. Before I start my presentation, because many universities in India are inviting us for the presentations, thank you for your support and expectations you are expecting from us. About my university, I am from University of Southeastern Norway, from the Faculty of Technology, Natural Science and Maritime. We call it as a TNM. And this is a view of Norway, where I'm located in Telemark region on the southern eastern part of Norway, from a location called Rosgrun. We have 8 campuses of our university, which is formulated in 2018, become a full university, serving around 700,000 citizens. I am from the Department of Electrical Engineering, IT, Cybernetics. We have bachelor, master's, and PhD programs. And these are our area of technological aspects, working for electronics, maritime transportation, climatic environment, oil and gas industries across Norway as global aspects of Europe and across. Our partners includes Sintef, large research center from Norway, local municipality which includes Skien and Porsgrunn. Our partners includes ABB, Skadrak Energy, Statkraft, Equinor, large offshore wind developers. Our focus is towards renewable energy systems, which includes onshore and offshore. And these are our facilities in the labs, which students are exposed to the industrial requirements. About 100 industries located in our campus nearby, which is called Hydro Helen, a park where we have 100 plus industries closely collaborating on oil and gas process control infrastructures in the laboratory aspects. These are some of the lab facilities we have in our campus, particularly focusing towards oil and gas. And we are also working more on electrical power system, control aspects on hydro renewable energy systems, modeling and control, particularly for sensor technologies, hydropower plant, monitoring, control, flood management, etc. Also on applied modeling and control for sensor devices, digitalizations, etc. These are a short introduction about my department and university. With this, I go towards my technical presentation, which where my past researchers, many students have worked on the aspects of inspiring power electronics in renewable energy systems. And thanks to ARIA Institute of Engineering and Technology for inviting me for this presentation. So if you look at Norway, on the aspects of particularly on electric vehicle, which is a governing field, in 2021, Norway reached around 85%. Now is more than 95% deployment of electric vehicle integrated with the hydropower plant for the charging stations, DC charging stations, and other renewables includes offshore wind turbines, onshore wind turbines, photovoltaic systems. The goal is to obtain 30, 35, 100% renewable energy system, but currently Norway has a clean energy around 99.9% because of the hydropower plant, sustainable energy. But in the future, we are going to have big problems when integrated with many charging units and renewable energy systems. So innovation of electronics is required for the existing power transmission, which needed to be incorporated with advanced IoT sensors, big data, cloud computing, machine learning algorithms for optimization, fault recovery, resilience, and other aspects of digital technology for smart power distribution with transmission and distribution to ensure the customers' high quality energy is available. So if you look at the overall power scenario, we have a power stations, which includes renewable energy and non-renewable energy, which includes fossil fuels, are given to the transmission systems and to the distributors. Then we have large electric vehicles. In 2030, around 350 revolving batteries will be revolving around the world. The small energy storage devices will be ideal during free time or in the night hours or during the charging periods. So these all batteries can pump the power through DC chargers towards the grid. So we will have bidirectional power flow, vehicle to grid or grid to vehicle communication in the future. Of course, each residential unit will have its own photovoltaic, wind turbines, small wind turbines, and electrolyzers to generate electricity to satisfy our own needs. Then we have our own grids which can communicate with the existing transmission distribution systems for pumping the power from the residential units towards the grid. Of course, we can get the power from the grid to the residential. It's applicable also for the commercial industries. So all these are integrated by using aggregator, centralized unit or decentralized units, which can monitor all the parameters, which can able to distinguish which is a clean energy, which is from the renewable or from the fossil fuel. All these are integrated with electronics technology. For example, in case of electric vehicles, we are going to use many DC to DC converters. So in the future, we'll have more vehicle to grid communication, grid to vehicle communication, home to grid and grid to home communication technologies. Currently, one of the focus towards renewable energy is large scale fuel cell technology because it has a high power gain. It can go from 1 megawatt towards 100 megawatt capacity, having a temperature capability around minus 20 degree to more than 800 degrees centigrade. Apply it for low power application or large power applications. Example, in case of electric vehicle, small vehicles or large vehicles, ship transportations, etc. Example, if you take a zinc air battery, which is can be adapted for a small power supplies or power scales. But if you look at the temperature or the degree, it can withstand from 0 to 80 degrees centigrade. And about the application, it can be adapted for less than 50 megawatt. If you look at proton exchange membrane fuel cell, which is highly commercially applied in real time, it can be adapted for large power systems or power transmission requirements or for large vehicles. And of course, it can be adapted between a temperature maximum 300 degrees centigrade, and it can be able to withstand the power capacity minimum 1 watts to 500 kilowatts. So there is a big market for fuel cell. Of course, Government of India has decided to go for fuel cell to be a large market by 2030, hub for hydrogen. In Scandinavian countries, particularly Norway, Denmark, Finland. In Norway, we have almost 95 to 96% deployment of electric vehicle based on batteries and fuel cell for high power trains. If you look at electric vehicles, we have a hybrid model as well as fully powertrained by fuel cells. In order to reduce the cost of fuel cells, because they are very expensive and the efficiency is only 60%, which can be able to generate the DC power. So it can be compensated by the batteries. Lithium-ion batteries are currently in the market, but they are limited with lifespan for 8 years, and state of the charge needed to be monitored. And based on the load conditions, if we can start and stop, the battery can easily deteriorate it. And these can be compensated by ultra capacitor or super capacitors, where we don't want to concentrate on state of the charge, and this can be charged from AC or DC. And of course, the powertrain are controlled by inverters, which converts AC to DC. So when you're applying the brakes, the regenerative energy will pump back to the batteries, and these are very dangerous. So it can be controlled by the inverters and DC-DC converters to control very effectively. The minimum efficiency of the system can be 80% from electronics converter to effectively use the 60% efficiency of the fuel cells. So that's very important. If you look at the efficiency is only 60%, but the electronics converters can go up to 99.x percentage. Large electric vehicles needs inside DC microgrids. They scale up from 400 volt minimum towards 800, 1200, 1600 volts. So high voltage requirements are required as a point of common coupling in large vehicles, which can be controlled from 600 to 700 volt battery controllers, large scale fuel cells, along with small actuator of electronics converters, DC-DC. Then on the right hand side, left hand side, you have the propulsion units, which can control from inverters. And of course, the inverters can be used for 20 kilowatt capacities and luxurious needs. For example, we develop many electronic converters along with our researchers, particularly focused towards industrial demands. On the load side, we use a standard DC-DC converter, which is a boost converter, but they are limited with power density, conduction angles, and of course, losses are very high. So we worked on the integrating the input grid side along with the load side converter. We included additional legs. It's particularly a H bridge inverter. And one leg we have replaced the MOSFETs by inductor, another leg we replaced by inductor along with the capacitors, so that it can be able to enhance the capacity of the converter on the input side to generate high voltage for an existing DC to DC boost converter. And this lake can be extended until the N level requirement of the power supply. Because of these modification, we term this converter as a triple mode, because this will operate in one mode and this will operate in two different modes. So we get 3 level of DC voltage pump on the input side. And this converter is called a triple mode active passive parallel interconnected DC converter we developed to maintain 400 volt DC bus requirement on the common point of coupling. And it can be integrated for charging units, photovoltaics, or of course you can able to use other applications of DC home. In the future, most DC home will come, where currently we are using for cameras, laptops, televisions, etc. On other side, generation units, we have large battery banks, existing transmission line, photovoltaics, or of course wind turbine can be integrated by two-stage converters. An existing transmission line be connected by using anti-parallel connected AC voltage regulators, and of course for the battery banks by using DC to AC converter. Then we are integrating by using AC to DC. So we are maintaining 400 volt by using our advanced converters what we develop. On the testing aspects, we tested in low scale prototype model for the safety reason around 500 watts. You can see the simulation model. The efficiency goes to 97.5%, but in real time, it's around 93.5x efficiency, because we are switching loss, conduction losses, other passive effects. If the converter is extended to high power application, obviously the efficiency goes near to 98% in real time. Designing the converter as a different modules. In the previous module I showed, we integrated on the input side. We also worked on the load side. For example, is a standard boost converter like the previous model, but here we integrated on the load side by using passive components, blocks that we called as an inverting n-stage multiplier, because each block of these capacitors along with the diodes will enhance the output voltage. We have one blocks we integrating in series addition. N number of blocks we can able to bring high voltage requirement for the different applications of electric vehicles or renewable energy integration. It has been tested in the real time by using FPGA solutions. You can see the size of the converter, which is a 140 millimeter in length and breadth with a height of 50 millimeters. Very compact structure. In faulty condition, the components can be easily replaced. Of course, it can be completely fabricated from the scratch. The most important is in real time is testing the dynamic behavior. We have tested in various aspects to look at the dynamic behavior charging or powertrain module. You can have a look how we regulated the load in voltages. You can have a look. The load voltage vary at different scale, whereas the input is always kept constant like a battery modules, and we are able to regulate the voltage on load as well as on the currents. You can have a look. It shows a very good performances on the regulation. We have two different mode of regulation. We regulate the load voltage for the requirement, or by regulating the current, we keep the load voltage constant. So many aspects we regulated this system to identify the dynamics. All the cases, the ripple content is within the limits of 1%, and that's very important, particularly on the aspects of batteries, where if the ripple content is very high, you damage the battery, and the lifetime cannot be very effective for 8 years. Of course, for fuel cells, they are very sensitive because these ripple content can easily damage the system. So this shows the clear spectrum of dynamic behavior of the systems. You can have a look. We are regulating from 80 watts to 100 watts, back from 100 to 80 watts. All the cases we are getting unaffected on the input side. Voltages stable like a battery module, whereas the current are regulated with 1% ripple factor transition, and this is very good for connecting with real-time renewables. In order to make a commercial model, we already patented the converter in US. Looking inside the dynamics, we also use many capacitors. You can have a look. We are trying to regulate near to 400 volts in numerical models. And of course, the current are regulated according to the load requirement. Current through the inductors are very smooth. Of course, the battery doesn't affect it. The most important is the voltage through the capacitors, because capacitor voltage, if there is a short transition or in the current or voltage, capacitor will blow off because capacitors are highly sensitive. That's why we tested in the real time. We have looked the same characteristics. We are reaching near to 400 volt, which is pretty near 395.5x volt. and the current are regulated very smooth. Current through the inductor are periodic, and most important, the capacitors. Their capacitor voltages are periodically regulated, doesn't have any spikes which can blow the capacitors very easily. Of course, we develop other electronics converters to integrate electric vehicles, home applications, existing AC grids, from fuel cells, photovoltaic, and batteries. And we invented another converter which is called three-state converter, because we use three MOSFETs. They are regulated at three different intervals. This is a load side converter, which is a standard boost converter. On the leg one, we replace one of the MOSFET by inductor L. On the second leg, we use replaced by another inductor Ly in combination with the capacitor. So when the device is closed, we energize X. When the device is closed, we energize Y. When the device is open, Lx will be delivered to Cx and Cy will be delivered to Cy, and these two are connected in parallel. We get a high voltage on the load side converter, which can generate high voltage. If you look at the gain, we got around 42 times at 60% utilization factor or duty cycle. When comparing to other existing converters, the most important is the loss distribution. The MOSFET produces 16 to 17%, diode produces between 4.8 to 5.2%, capacitor 6%, and inductor around 9%. After all detection of these losses is done, we tested in the real time. The voltage pumps to 395.5 volts, which is required here. So we started with the low scale. Now the scales are pumped to 800, 1200, I said. Then we look the voltage across the diode. They are forward biased, pumped to 185. MOSFET pumped to 185 again. The current through all the inductors are very smooth. We are very curious on looking the current here because it's directly coupled to the renewables. So they are periodic, ensure proper dimensions. And you can have a look how we are regulated dynamic behavior regulating the load side. We pump from high scale voltage to the low level around 395.2 volts. We are not getting 400. It's not possible because of the losses. It goes down to 206. All the cases, the input voltage maintained at a battery module. Regulated current through the inductor are periodic. Load current are very smooth. We ensure the power quality requirement for IEEE standards. And you can see the converter, which are like a compact module. And how we regulate these voltage? First case, the two MOSFETs is conducting like 50% and 35%, whereas the third MOSFET is always kept at 50%. Last case, we kept two MOSFETs are conducting at 35%, the last one at 50%. So that's why we get 206. So you can have a look, all the cases, we are not exceeding the conduction of the MOSFET more than 50%, which ensures the conduction loss are limited. It's not only the continuous mode of conduction, it's also very important during the discontinuous mode of operation. You can have a look, we develop another new electronics converter, which is a static module, where we try to regulate the existing static converter, which are used in high power train like forklift applications, where the power density is limited, efficiency is limited. But with our modification, you can have a look, we introduce Lx and C1 in combination with D1. This module makes the converter totally different. When the device is closed, we energize X. When the device is open, the energized X will be delivered to C1, Ly will be delivered to C2, and add up to produce a high voltage on the load side. If you look at the efficiency, we tested around 100 watts capacity power rated application. The efficiency is around 91.4x. But if you increase the power, because these converters are designed for high power, we are testing at very low power. That's why the efficiency are limited, and the device produces around losses 47%, diode 12 to 13%, inductors greater than 1% to 10%, capacitor 5%, and combination of these three, the passive component around 0.4%. The most important is the regulation during the nonlinear activities. You can see the diode is giving two peaks, 92 volts and 152 volts, because we are working in a highly nonlinear mode. And the current through the inductor goes to the peak, comes to the zero, which ensures highly nonlinear discontinuous mode of operation. Still, we get 92 volts. This is very important because all the components are nonlinear in characteristics, particularly inductors and capacitors. And of course, the electronic system is not linear. And even in a high frequency operation, we call it technically DCM, still able to produce 92 volts. If you look at linear proper operation, it's a little battery module, 24 volts, pumps to 172. So when in a linear mode of operation, continuous conduction mode, all are proper. Current through the inductor are very periodic, and doesn't goes to zero. It fluctuates between 1% of the ripple content to ensure the power quality. So we developed many power electronics converters in real time. Capacitor based module, inductor based module. These are our converters. Of course, multi-level converters, XY families. And we compared with resonant converters, which is used only for high power applications, whereas the reliability is average, cost is very high, efficiency obviously very good because of using high frequency transformers. They use soft switching, tunable ratios, and high power transfer ratio is possible. But losses is very high because of the magnetic circuit and bulky in structure. But what the converter we developed based on capacitor modules are used for low power. Of course, inductor based also used for low power. Multi-level converter stage, what we develop used for high power applications, and XY family are applicable for both low power and high power application. The advantage, we use only one MOSFETs or IGBT, extendable structures. Disadvantage, we use many diodes which can create discontinuous current, which I showed you here as an example. And we also work on AC power converters, which has 6-phase converters, which can propagate from 4 different inverters, regulated like a multi-level converter, which can be fed from batteries, fuel cells, photovoltaics, wind turbines, etc. You can have a look. It works like a multi-level converter, able to generate 9 level, and the fundamental components of few sinusoidal with reduced harmonics, and the line voltage can go up to 5 levels. So it's work like a conventional H-bridge inverter, work like a multi-level inverters. So once we design the converter, AI come to the application. I am not going to make you more complex. Simple application I like to explain here. We have hybrid renewable energy system. One is wind turbine, photovoltaic, batteries are integrated to the same centrifugal induction drives. Why we use centrifugal induction drive? Because it's more reactive. You produce more reactive power. How these application makes unity power factor with our application. So we dedicated a multiple AI algorithm. One will control photovoltaic, one will control wind turbine. For example, ABC controls wind turbine, and particle swarm optimization controls the photovoltaics. Of course, it controls duty cycle of the inverters. So we have a multiple AI algorithm in one platform, multiple renewable energy system in one platform. So it's like my hybrid renewable energy systems, hybrid AI algorithm in one platform. It's a very complex system. Please note, use only one wind turbine, one photovoltaic, one batteries. If it is going to be a large power system, the complexity increases. So in this case, we use only 50 hydration, and runtime is only 15 seconds. And the desired error is 10 power minus 6. We use, these are the parameters for on-B lookup for our own ABC control algorithm. What we propose, we feed all the parameter into the MATLAB, then we calculate the fitness function. We try to estimate what is the feedback from the current voltage from the induction drives, and we do the 50 hydration, and we stop, and we find the exact requirement for the induction drive system. So this is a simple example how we done. I didn't go for a very complex vector control. We sense the speed, reference speed, what I want to drive the induction drive, and feedback is taken from the induction motor, given to the piezo regulator, which is our own algorithm. We doesn't use any PI regulator. So this will perform like a piezo. What is the advantage? During the low speed, it behaves very dynamic when compared to PI regulator, which is given to generates the synchronous speed, compare with the actual speed of the rotor, add up, we generate slip. Slip is given to the V by F controller, where we calculate what is the frequency and voltage, and we convert these signals into 3-phase, 3-phase into 2-phase, where alpha controls the flux, beta controls the torque. Then we given to the modulation system, which controls the inverter for the required speed, torque, etc. Why I showed you a V by F control, V by F control are not good for low speed. For example, if the drive is running at 1450, induction drive is fine. 1000 is fine, 750 is fine, but low speed like 50, 60 revolution per minute, the PI regulator will saturate. It cannot control more than 50 to 60% perturbations, but piezo is vital. It can be able to control a full margin. That's why we proposed this module as a base example. And how it works, we start the program, we try to provide the basic parameter for the particle swarm optimization. Then it will require the fitness function. It generates its own value for Kp and Ki. There is no integrator in the piezo model, and we run the motor. We find all the parameter. If it's okay, it's fine. We stop the hydration. If not, it will update until the required regulation is attained. You can have a look how much perturbations are available from the photovoltaic power plant. There are huge oscillations in the current, voltages, of course, in the total power. Our goal is to maintain the maximum power point. You can have a zoomed view of the voltage, the current, and the power, how much fluctuation is available. But if you look at the characteristic of the drive, the current is very smooth, sinusoidal. There is no any oscillation. You can have a look on the speed. It's very smooth. After perturbation, we create a lot of perturbations. The torque is very smooth. The most important, the DC bus link has a pure spectrum of DC voltage, doesn't have any high frequency signal. Even it is regulated from the photovoltaic panel. You can have a look how much regulation we are doing from minimum to the maximum, maximum to the minimum. That's why you can see here the perturbation periods. And all the cases, the real time, we get suppress all the DC bus with minimum pulsations. High frequency signals are suppressed by using LCL filters and high frequency filters on the input side. Apart from that, our AI algorithms regulate like a filter so that it suppress all the high frequency signals for the protection. You can have a look all the cases. We are getting unity power factor on the drives. Photovoltaic is plumping at different scales of insulations, created from 1000, 500, 800, instantaneously 300 back to 600. The current doesn't affect. Of course, the DC bus are very smooth. You can have a look how much errors we are creating. Number of iteration required is only less than 10 for ABC algorithm, what we proposed. And the error estimated is 10 power minus 6, but we got much less, 10 power minus 9 when compared to other algorithms. So our proposed algorithm has a very high good convergence speed. Of course, very less error are detected when compared to other existing algorithms. And this will show you much clear spectrum, creating different insulation patterns. This is created by the conventional PSO. You can have a look during the steady state or during the transient condition. There are huge perturbation, oscillation is available. More time is required to recover back to the rated value, of course, by using AND colony algorithm. But with our proposed model, you can have a look. It requires a very short time to overcome the perturbation or insulations created by photovoltaic, wind turbine, batteries, etc. And our efficiency of the algorithm, not the overall system efficiency of the algorithm, always near to 100%. And this is another example how we integrated the modern IoT sensors with the grid and how to control the photovoltaic system by using combination of hybrid AI algorithms, which includes ANFIS, neural network, fuzzy logic, and particle swarm optimization combined together. And this is our developed power electronics converters. I'm not going much inside Zeta converter, which can able to stabilize high voltage for the grid side. So what we are doing, we use first stage fuzzy logic controller based on the lookup table. It will be fine-tuned during the execution. We adjust this algorithm. It's not standard. We have to adjust during the runtime. Then the output of the fuzzy logic will be given to the neural network. Neural network will develop the output. Then it is given to the PSO. You can look at here in the MATLAB. We collect the data from the PV, current, voltage, etc. Then given to the fuzzy logic. From the fuzzy logic, we find the output and given for the errors. Then given to the neural network. Neural network, we find what is the error. If the error is within the limit, we given to the PSO. If not, we train again. If the errors are minimized, we given to the PSO. Then again, we check the error is much less than 10 power minus 6. Is okay. We stop the regulation of the AI algorithm. If not, again, we start from the beginning. So this is the testing module environment, how we are regulating this in real time with a minimum number of hydration 50, because the processor doesn't support for high number of executions. So we took 49 rules, minimum requirements. The number of epoch we choose around 100, inertia which is around 0.8, and number of iteration is only 50. You can have a look how much distortion produced in the voltages and in the current, 2.6 and 2.8 in the current. You can have a look how much distortion is created in the photovoltaic power as an example. And we are creating a lot of insulations at different time intervals for the power, current, and voltage. You can have a look. But if you look at on the DC side of the inverter, we have a stabilized voltage and current, and unity power factor is always maintained, which is very important when we driving this application with different synchronization issues. If you look at with the grid synchronization, the grid voltage is stable, where we are regulating the grid current from minimum to the maximum, maximum to the minimum. All the cases is very stable. Unity power factor is maintained with the induction drives. You can have a look. All the cases, huge perturbation is coming from the wind turbine, batteries, photovoltaic. Still, we are able to maintain the grid synchronization properly. Doesn't trip anyway, or we are not creating any faults. All the cases you can have a look. We have produced the tracking time is less than 1 second. That's pretty good. And this is the conventional particle perturb and observe method. All the cases we have a lot of oscillation in the spectrum, whereas with our proposed module, we suppress all the oscillations with the power, voltage, and current. And this shows you the advantage. Our proposed module always required root mean square error less than 0.33. The most important is the algorithm efficiency. We are always keeping around 99.9%. We also adapted IoT sensor to improve PSO, because you can see when we adapt IoT and PSO algorithm together, we reduce the computational burden, behaviors, simulation period, accuracy is very good. If there is no cable connection between the processor and the sensors, so we reduce the cable losses. Tracking velocity is very good. Complexity is moderate and cost is also moderate. How we calculate all these efficiency for the algorithm? An example for photovoltaic, we calculate the efficiency of the AI algorithm. We calculate what is the power extracted at the MPPT at Tmax divided by the maximum available maximum power at Tmax. So this algorithm we propose. You can refer our papers where we derived theoretically these equation and how we validated 99.98 accuracy. This is an overview. You can have a look how conventional perturb and observe algorithm behaves in real time during insulation period, during the steady state period. Persistent oscillation is observed. It's not good for the complete system. It can generate zero sequence component, vibration in the network, and of course create high frequency signals which can spoil all the components within the power network. But with the proposed modules, you can have a look how we suppress. We can't bring 100% oscillation free. It's not possible. But we perform more accurate to bring all these oscillation much suppressed in the system to create a minimum distortion around 2.8% with a high power quality power distribution. With this, I finish my presentation. In the future, we are going to use more photovoltaics and fuel cell powertrain in the market. We need to design power electronics converter, the prerequisite for modern microgrids. Of course, battery technology needed to be overcome with lithium-ion batteries. We need to use supercapacitors and other technologies in the batteries. All these renewable integration will create a lot of instability in your grid. So we need to overcome harmonics, voltage sag. We need to go for advanced grid, smart grid technologies. Future aspect will focus more on vehicle to grid, grid to vehicle, home to grid, and grid to home technologies by introducing smart meters, which includes IoTs, integration of renewable energy systems, system penetration. There are many challenges we have to overcome. All these can be overcome by using hybrid AI algorithms for precise and accurate tracking with high speed velocity to regulate all these systems. IoT sensors will come into the pictures for tracking high efficiency and of course for self-recovery and resilience. All these hybrid algorithms will play a critical role. With this, I completed my presentation. I want to show you some example how our students are working with us in developing the real-time modules in real scenarios to execute the projects. This is a recent project developed by my master students, Megatsuri. Thanks for him. You can have a look how we are integrating large-scale photovoltaic systems, batteries in real time and monitoring all the parameters on the desktop. You can have a look. The photovoltaic panel is integrated with the batteries. and supercapacitors and testing state of the charge of the batteries in real time. Same module apply if you go for a large power systems, and the inverters are integrated in the modules by using Typhoon Hill modules. You are testing in the lab scale, and LCL filter to reduce the harmonics requirement to the grid stability. And these are tested with industrial standard module of testing. Parameters are designed, and frequency locking with the grids. Real-time controllers used to control by using vector control. You can have a look how the interface are tested in real time with controlling the maximum power point tracking from the photovoltaic panels, creating a lot of installations. You can have a look before the grid synchronization with the filters. A lot of harmonics are generated. After the filter, you can see the clean spectrum of AC currents, and regulated currents are very stable. Voltages required for the common point of coupling to the grid, which is around 400 volt, and the total power voltages are shown here. Then active power and reactive powers are shown here, how it is regulated in real time. Harmonics values are shown, and now you can have a look how the power is regulated, very low power, regulating from maximum to the minimum. You can have a look how much harmonics are generated from the inverters, but they are suppressed by using LCL filter. Clean spectrum is maintained here towards the grid, and at the same time, maximum power point tracking is maintained from the photovoltaic panels. You can have a look how much harmonics are suppressed with the grid systems, and these are done in real-time simulation modules testing by the students to understand the dynamic behavior of the systems, various parameters simultaneously controlled in one platform. You can have a look how active power is controlled from maximum to the minimum, minimum back to the maximum, and these are done simultaneously in real time to capture the more realistic scenario. Thank you very much. If you have a question, I'm happy to respond.
Thank you, sir. In spite of a busy schedule, you have given time to us and present us the.
Yes, I'm sorry because a lot of
Thank you.
activities going here, and
Yes,
really is. Thank you very much.
Thank you a lot, sir.
If you have a question, I'm happy to respond to your questions.
Sir, excuse me.
Any questions?
Yes. Any questions from the audience side?
If you have a questions, you can pop up me on my email. Is always welcome. Share you in.
Thank you, sir. Nobody have no questions.
Thank you. Thank you for. I wish you good luck with
thank
this
you,
FDP program. I thank you all for your invitation. See you all. Bye.
Thank you, sir. Thank you very much. I think the session, sir, will represent. We can do in the application of drone in the UAVs, showing through the extended flight endurance and power sources. As I told, the smart power management system and drone require highly efficient and lightweight power electronics in hybrid or renewable power like the solar power drone. Some fuel cell or in battery hybrid system that AI can manage the power flow between a high energy source. Autonomous and enhancement operation like AI for navigation or control, predictive maintenance for drone system, or maybe in AI enhanced missions efficiency. Sometimes remote sensing or inspection, the drone are highly equipped with their camera, thermal image, or lidar, like that. So overall, it's the impact of the smarter or more longer lasting drone that can execute complex or some missions for application. So thank you for today's session. We will meet you tomorrow at 6 p.m. Thank you all. Thank you all for joining today. If any query or any doubt, you can WhatsApp me or mail me. All the resource person PPT file I will share to you. And always be there in the recording session, since all things will be going in the recording session. So all of you, please be in the Google Meet, or you remain in the session. As I say, your NCR attendance will be recorded. So you will be sent all this recorded as a, your attendance will be verified maybe by the author. So be there. Thank you. Good night to all of you.